You put them over here. Again, should be enough. Whole purpose of this is to make sure that you remove two variables that are very correlated with each other. Now, as I said before, in very large data set, you don't need to worry about it. But in small data sets, you need to worry about this. If two variables are very closely related to each other, you cannot add both of them. So let's say, classically, I would say coagulopathy and alcohol might be related with each other. So you go down, you find coagulopathy, 1, and then you see what's the association with alcohol. So not a very strong relationship in this group, but that's how you find out relationship. So this 1, right side, left side. So 1 is most associated with electrolyte abnormalities. 0.1, you can see they're closely associated. And if you go like this, the next closest association is cerebrovascular disorder. So you have to kind of put in your mind, what do you want, what do you mean by correlationship? So usually I would select as 0.2 or 0.3 as two variables being very closely related. But you can go up to 0.5. So if you find like a variable, like 1 is related very closely to something else, like this variable, so then you have to remove one of them. You can't keep both of them. But this is very important in smaller database. In large database, the data is so big that you don't need to worry about it. Second thing is regression. Once you do this, you select your final model. You just go to binary logistic regression. Your outcome variable is going to be up here. So you want to see predictors of mortality, you put that here. Then again, you select sex, race. Now this data set doesn't have a lot of mortality outcomes. Just keep that in mind. So you might see weird results here. But if you want to study, let's say, something that has high mortality like septic shock or cardiogenic shock, you don't need to worry a lot because your event rate is very high. This is just Watchman procedures data set. So I just select the variables I want to, I go to categorical. The categorical variables I have to move over here. I have to select first. Then I have to go and select confidence intervals here. These are your significant testings, but you don't need to worry about it because it tells you how good your model is. And this is a kind of a subjective thing. So I'll run it this time, but you don't really need to do that. So these are different kind of methods. You should try all of them and then see which one you want to use at the end of the day. Enter mean you use all these variables at once in the model. Forward conditional would mean that you would start using one at a time. So it will start with female, then it will add race, then it will CHF, then it will add coagulopathy, and it will stop when it finds there's no difference or no improvement in the model. Then it would stop. So for small data sets, this is a good idea. But the problem is that using this thing, it might just miss a couple of more variables. So the best thing is always to use minimum amount of variables that you think are clinically significant. After doing a literature review, only add those into your data set. So that would be the best thing to do. Because forward conditional, again, you might miss some important variables. Backward condition is that it starts removing variables until it finds that there's no change in data set, no change in the model improvement. So that again has its trouble because it might remove significant variables. The computer doesn't know, it's just trying to run a mathematical model. So you have to make sure that you put incorrect variables in this model. And one of the way to find that is using a bivariate analysis. Like the last session I said that if you have greater than 0.5, that's a strong association, or if your p-value is less than 0.01, less than 0.1, that's also a strong association. So that's what I usually use, but you can use any cutoff. You just need to be consistent for that cutoff. So this is how it's going to look like. And these are your p-values, and these are your R ratio. So because mortality is so low, you see it's not giving you any results in race. But CHF is associated with higher mortality. Coagulopathy is associated with higher mortality. So it really depends upon your event rate, how many people died, and your mortality. If you go, this is the model testing. So it tells you how the model works. So here the p-value is 0.035. For any p-value less than 0.5, it's actually not good. It tells you the model is not a very good model. So it's kind of opposite. That's how you can remember it. These are two other tests that you can use instead of the Homsier-Lemshow test. Again, the same thing. So if your p-value is significant, it means that the model isn't good. And that is pretty much obvious by looking at the results. See, like, we have so many errors. So that's regression. Next step, I would say, how to plot this. So there are multiple ways to do that. You can either do it in R, or you can do it using an Excel sheet like this one. I'll share with you guys this sheet. You just have to put your values here and then here, and it's going to generate a figure like this. But this might be a bit tricky to adjust. The easiest one is actually the R one. Okay, all you have to do is just remember a code. So I would just go through the very basics of R. So R is just like a command promote program. It kind of, you have to type in all your codes. This is basically your history area. This is your typing area. Here you type your command. This is where your plots are made. But you can also look at your files and packages and everything else that you have. And this is also an additional area where you can look at your history or your files. The first step when you open R is you want to go browse and find which folder do you want to work in. So this is what I'm browsing. I'm browsing into like files and go to a folder, and I'm going to set up a folder. This is the folder I want to work in. So you click here, set as working directory. The command also comes in case you want to type it very fast, but this is the easier way to do it. So now the working directory is set. The second step you want to do is read the file you want to use. It seems I don't have any file here that would open. So let's go to something else. So this file I can open up because it's a CSV file. So you have to copy paste your results again from here into a CSV file. Just copy it and you create a CSV file. The CSV file is created in Excel. You can simply do blank work, paste it, then save it as CSV. Select the area to save, and in here you have to select CSV. So an example of a CSV file that I made is here. You should probably follow this format because Let's get to, so this is how it's going to look. So you have going to have one column, your variable, then this other column that I don't use a lot. So I just didn't label it at all. This is your p-values. Then label this one as odd ratio, the lower odd ratio, the higher odd ratio. So if you want to open up an R, you have to use the read command. So you have to just write read. You want to open a CSV file, and then you just write the name of the file. I'm going to kind of give you guys the one of the like a history file, so you can do it very easily. So you have to name the file that you want to open, which is book1.csv. And then this basically means to open it up in a standard format. So unfortunately, you have to put this as one file encoding. So this is a file it read. Now you want to change this file into a data file. So we just have to name it something. So this means that I'm naming this file into this. If you go here in environment, it should pop up right now. So now you can use this file in multiple ways. So you can, the next step would be to create a graph, because that's what primarily you're going to use R for here in this. So you can, first thing you need to do is make sure that arrangement is kept intact. So this is that code. Basically, it means that it's not the right code. So this basically means that the file is going to be kept in order when you create a graph. That's what it really means. And then this is your ggplot code. So this is, it made a graph here. I think the problem is it didn't read the data. That's why it's all, everything is zero. That's something happening. Yeah, the file is not, it's empty. So maybe that's why it's use. So in summary, if you want to, you're going to get, I'm going to like send you guys these codes, but the simple way is to first set up your working directory where your file is located that you want to create a graph from. Second would be to read the file. Afterwards, you need to make sure that the file is listed correctly. So it's this code, and double click here on the history file, it's going to come up. Then you open the ggplot package. And then you create a plot here. So that's how you're going to do it. This file is probably not, is corrupted. Let me see if I can find a new file. So in short, R is pretty much complicated. But let's try it again on a different folder. Right here. Let's go to different project. So this is a history file. So I'm going to send you guys this file. You can just double click it and a lot of history is going to pop up on this side. So again, set up your working directory, which I'm going to set up as the same. Then click your read file, which is this. Make sure this book one is the same as the one you're here, which is book one. Double click it. Next step would be to click this, double click, then ggplot, double click, then this code. It's giving an error, which you can see it's CA low CMX. It's probably labeled incorrect here. So what this means is ggplot data is your file, which is named data here. So you don't need to worry about it. This is basically mean what is going to be your X variable and what's going to be your Y variable. So your X is going to be just a variable column, which comes up here. The odds ratio is going to be data odds ratio. Your Y is going to be the lower confidence interval, and your is going to be your higher confidence interval. Should work now. Now this is, so basically the code runs like you have to first specify which file you want to run, which is data, then you have to specify which is X, which is Y, which is the Y minimum. So this is all Y axis. This is your X axis because it's a flipped graph. So these are your X axis, this is your Y axis, this is the maximum, this is the minimum. So confidence interval minimum, confidence interval maximum. So that's what this graph shows. Then this tells you where is the intercept line, which is at 1, you can see. Then this tells you to flip the graph. So it's a flipped graph, this is X, this is Y, it's kind of flipped up. This tells you the labels which are left empty, X-axis, so it's empty, there's no labels here. On Y-axis, I put odd ratio. The theme is, you can select different type of themes. This is a black and white theme, but you can also change to classic or something else. Then this is the title. So better to edit this when for your own project. So predictor of mortality, you can do something else. So the way to do that would be simply double clicking the history file and then editing it. So I can change this to something else, figure number to something else, list to something else, and it's going to come up as such. So you can see the difference. So I'm going to send you guys a history file, and that should make it pretty straightforward. All you guys need to do is install R, then install ggplot2. The way to install ggplot2, I think I showed you the other session, just to install packages and you write ggplot. There are several other things you can do with ggplot. So if you learn ggplot, you can make every kind of figure with it. This is your regression portion. You guys have any question on regression, data sets, data tables, and then we can start coding. Okay, good. So So onboarding is done in two ways. You can either go to data, compute variable, you can go to data, select cases, or you can simply write a syntax code. That will be through new syntax. So let's assume this is your main SPSS data set that I would share with you guys at the end. And you want to select only cases with heart failure. So there are two ways to do it, either through syntax or through here. So here you're going to do select cases and you want to select only heart failure. So you go to heart failure and you just say is equal to 1. You continue, you copy to another data set, name it as this, and it's going to get copied. So you have a new data set that opened up. It's going to take a lot of time with large data sets, but here is the new data set, then you can just save it. If you want to do it through ICD codes, again, same way, just data, select cases, if, and you paste the code here. An example of a code would be AKI. If you want to select AKI cases, this is a code written already. You just select it and paste it here. It's giving you error because you need to end it. You shouldn't put a code at the end. And the same way, it's going to select cases. So that's how you select cases. The other way to do it is obviously a syntax. So you can open a pre-written syntax, or you can write and just open up a file that you have already written. So let's say I've written a syntax for CKD. I'll just open it up. And you can see, you can create variables here. You can also ask them to kind of save it as another file. I would just create a variable and then use the simple method, the one that I initially showed, like CKD is equal to 1 and then select it. I can share with you syntax that I have as well. Now, the real question is how to write a code. So that's also pretty straightforward. So you'll be working basically in two things. Number one would be selecting procedures. Number two would be selecting diagnosis. So for procedure, you can write it through different ways. And there are like literally hundreds of ways to write a procedure code. So let's say this is one way to do it. It's a subtract code, meaning that in diagnosis 1, remember NIS has diagnosis 1 to 30. So in diagnosis 1, I'll start from the first variable of the code. Actually, I've written instructions here, explanation. So let's say a code is 8245. So it's telling, so ICD codes are hierarchical codes. So 825 will be, let's say, kidney disease. And then 82451 would be acute kidney injury. Then 82452 would be like chronic kidney injury. So they're kind of subgroups. So if you select 8245, you can select all these subgroups. That's what this code is. Usually used to select a big code. If you're like 30 different codes, you can select all of them at the same time by just using this code. So you say 1, I'm getting this example, so I need 4 digits only, and it's 8245. I'll just write 8245 here. And I can do that by using a replace code. The same way you fill up this, make sure at the end there is no, so this indicates R. So we want to see if kidney disease exists in code 1 or code 2 or code 3 or code 4 and so on. So in ICD 9 it runs till 30, in ICD 10 it runs till 40. So this is an ICD 9 example. You can use this basically to even select a code like this. So this one you can use for anything. So I'll send you the template for this one as well. And then for ICD-10, it's the same way exactly, you just fill it out. So if you want to select a single code instead of this, then you have to use any code. So it means that you can use this. So just write up the code here and it's going to select the case. Procedure is the same way, but it's just named as PR. So that's how you code. And the way to find codes is through these websites. These are HCAP on website. I think I shared the links. If you want to see chronic kidney disease, you just say Control F, you write kidney, and you have like all the codes here. So this is kidney tumor, malignancy of kidney, neoplasm of kidneys, all sort of chronic kidney disease, CKD 1, 2, 3, 4, 5, 6, all of them are here. This is that huge list that has all ICD codes. So I'll share with you guys this as well. But that's pretty much it. Not very difficult, but it all requires practice. When you're doing it, you're going to have a lot of questions. Just text me with questions and we can troubleshoot as we go, but that's basically it. The last step would be like the other complicated, like propensity match. I'll teach you how to do it, but you need to install this this add-in. It only works on version 24, so you need to have SPSS version 24. So I'm going to end the session here. I'm going to send you guys this video and the first video as well. So just make sure you remember all your keys. Data, how to open a data, how to open a syntax. This is where you select your computer variable. This is where you select your cases. This is where you analyze your data, means, tables, regression, and correlation. And of course, I think we didn't do trends. We can just go through all of this again next session, and I'm going to start giving you guys some small projects, and you can try doing that. I think Faisal and you guys already did something with Salman. It's pretty much the same. The new thing would be coding. I'll share with you guys these files. So